In this video, I'm going to go over some of the calculations you will need to do in the mold lab. The top of the front page is all about data collection, and that stuff is really straightforward. You're just going to get the mass of a couple different objects that your teacher has given you. The part that's going to take a lot more effort is the calculations, and that's what I'm going to go over some of that with you now. So in this first one, you're going to get the mass of a nickel, and it tells you that the nickel is made up of 25% of it, 25.0% of it is the element nickel, and 75.0% is the element copper. So if you want to figure out how much of the element nickel is in that coin, what you have to do is start off with the mass of a nickel. And I'm just making up this number. Do not write 3.50 grams down on your paper. But let's just say in this case that you start off with 3.50 grams of that coin. And what you have to do is to figure out how much the element nickel is in there. You have to take this percent and change it into a decimal. So that becomes 0.250. Remember, you move the decimal point 2 places to the left. It's like dividing by 100. Now you're going to get an answer here, and that is going to be the amount in grams of the element nickel in that coin. Now pay attention to significant digits. Depending on the type of balance you use, you might not have 3 significant digits. You might have more. And then pay attention to that 25.0%. That's why I wrote it as with this 0 at the end to match the significant digits in the problem. But you're going to get an answer there, round it off for significant digits. And what you want to do in the next step is you start off with that answer, the amount in grams of the element nickel. And it says to calculate the number of moles of nickel in that coin. So you're going to start off with grams of nickel. You're going to have to set up a conversion factor. And since you start off with grams of nickel, that's what's going to go on the bottom. And if we're converting the moles, moles of nickel goes on top. Now when you're doing a conversion factor, the number 1 always goes with moles. And to figure out the grams, you have to look at a periodic table, and you get the molar mass off the periodic table. It's the same number as the average atomic mass. It's just that the units change from AMU to grams per mole, which is why we always use 1 mole. It's however many grams are in 1 mole. We put grams on the bottom because we want the grams to cancel out. The molar mass of nickel is 58.7 grams of nickel in 1 mole of nickel. You're going to get an answer here. Round it off to the right number of significant digits. You never use the conversion factor to calculate significant digits because there's no uncertainty in this number. It's said to be an exact number, so it has an infinite number of significant digits. It's like saying there's 60 seconds in 1 minute. They have an infinite number of significant digits there. There's no measuring that we had to do to get that. So you're going to get moles of nickel. And again, round it off to the right number of significant digits. The next part is calculate the number and kind of particles of nickel in the coin. When it says kind of particles, a lot of times people get confused on that. Really what's going on is, since we're talking about an element, the type of particle is an atom. So you want to start off with the number of moles you had in part B. And we're going to do another conversion factor. Since you start off with moles, moles goes on the bottom, and we're converting to, since kinds of particle of an atom, the type of particle, well, kind of particles of an element. So the atom is the unit we're going to use. And again, conversion factor, number 1 goes with moles. Now we need a really big number to go with atoms because they're so small, and this is Avogadro's number, 6.02 times 10 to the 23rd. Pay attention to how you put that number in the calculator. You want to make sure you have the right number of exponents and all that kind of stuff. When you get an answer, you're going to round it off, and that's going to be the number of atoms of nickel in that coin. Again, do not use the conversion factor when you're rounding off. You're going to go by this number, which really just carried over from B, which is significant digits carried all the way over from A. So your significant digits should follow you throughout this problem. Now the next page starts off asking about how much copper is in the coin. You're going to do the same general idea here. It's just that you want to remember that copper made up 75.0% of that coin. So you're going to do the same general thing, use that percent, and remember when you're doing molar masses, you're working with copper now, so you're going to have a different molar mass than you did for nickel. Alright, for the second one here, it says the number of moles of water swallowed. Now, Again, don't let the wording confuse you. If you ended up getting a paper cup from your teacher and you went down to the water fountain and you actually drank the water, that's fine. If you didn't want to drink the water, or you didn't walk down to the water fountain, you just used sink water and then poured it out because you don't want to drink the water from the sink, that's fine. Or if you had a beaker, you definitely don't want to drink the water from that. But it's how much water either you swallowed or you poured out. You're going to start off with a mass of water here. And again, pay attention to the significant digits. Now it's asking you to convert it to moles. So since you start off with grams of water, that's H2O, and it's asking you to convert it to moles of water, you're going to put 1 mole at the top. No idea what that is. So again, number 1 always goes with moles in the conversion factor. The grams of H2O you get from the periodic table. Now this should be pretty easy to figure out. Oxygen off the periodic table is 16.0. Hydrogen is 1.0, but there's 2 of them. So you're going to get 18.0 grams of water per 1 mole of water. So when you do this math, you're going to end up with a certain number of moles of H2O. And again, round that off using the correct number of significant digits you have from over here. You don't use the conversion factor. Now it says calculate the number and kind of particles. Now the kinds of particles, it's just nomenclature here. We're not going to work with atoms anymore since we're talking about a molecule or a covalently bonded water molecule. Really the kind of particles are just going to be molecules, but we end up having the same idea. You start off with the number of moles of H2O that you got from the previous step. So moles of H2O is going to go in the bottom. We're going to put molecules of H2O up top. 1 goes with the mole. The number of molecules, you're going to use Avogadro's number here. All right, it's how many particles are in 1 mole. It doesn't matter that it's molecules instead of atoms. It's still Avogadro's number. So you're going to end up with an answer here is the number of molecules of H2O. And again, round it off for significant digits. Now the next part, table sugar is sucrose, C12H22O11. Calculate the number of moles of sugar in the packet. You're going to go from grams of sugar to moles, using the conversion factor similar to the one above. Then you're going to go from moles to molecules, using Avogadro's number again. Now part C is a little different. What happens is it says calculate the number and kind of particles of carbon in the packet. Well, you're going to figure out the number of molecules in part B. That's what you're going to start off with. Number of molecules of C12H22O11. Now what it's asking you to do is figure out how much carbon is in there. Well, if you start off with molecules here, you're going to have to put molecules in the bottom. And what we want to know is how many grams, or I'm sorry, not how many grams, how many atoms of carbon are in 1 molecule. So I'm not going to write it all out because I just kind of told you what the conversion factor is. All right, so how many atoms of carbon are in 1 molecule? Since you're talking about just a single element, the units now become atoms. For step 4, you're doing the same general idea, except we're working with calcium carbonate. So you have to come up with the formula for calcium carbonate, because that is an ionic compound, and you should be able to name that at this point. And you can go through the same general steps to figure out how much oxygen, or how many atoms of oxygen, were in your signature.